Colin, thank you ever so much for your presentation. I really enjoyed listening to that. Now, I was really interested to hear about the distributed manufacturing strategies versus traditional distribution methods, which you've advocated for. This kind of approach could really encourage the use of local resources by small companies, ensuring faster response to community need. So, how important do you think this will be sort of post COVID? And do you think that this is going to encourage more startups and spin outs to develop technology in the future?
It definitely, I really think it does. So, like, COVID for me has been a really, the best use case you could imagine for distributed manufacturing. We had border closures, we had transport disruption, we had resourcing problems. It was the impetus for companies and organizations to look more at localized production and kind of decentralized manufacturing. So that acted as a really good case study for it. But post COVID, I think with the world we live in, with rampant global warming, with increased global inequalities, local manufacturing and kind of this distributed manufacturing model is going to become more and more important in how we build things and how we support other people in building things. So I would assume that there is going to be a big kind of a huge increase in startups and spin outs developing to cater for this space. So historically we've been manufacturing the same way for the last the last few hundred years, from a big industrial facility in Birmingham, let's say, to Henry Ford's production line. That's how we made things. We made small variations of products in huge numbers. Whereas now in the digital world, where everyone wants a special custom piece or object produced ethically and locally for the lowest price, delivered quickly, we're going to move into this world of like mass customization. You can't really produce a million of one thing. If your million customers all want a million different things, you can then just produce a million variations of the same thing. And if you're doing that, you might as well produce it locally. Could then you reap those benefits of reduced global emissions, faster transit times, and then generation of more local employment opportunities for people. So I really do think it's going to become a very disruptive, but also a very important aspect in how we engineer and how we manufacture goods and services and everything going forward.
Yeah, I think you're absolutely right, and I think in terms of this is not just particularly, for all manufacturing sort of industries, but certainly the healthcare market. I think is going to really benefit from this kind of approach, isn't it? Because in terms of personalised care that we're trying to build towards, this is a prime example of how that sort of industry is going to really benefit from this distributed network.
Exactly. Yeah. Yeah. Medicine in particular was one of the real kind of first use cases for this. Some of the work I've done with my foundation a few years ago was manufacturing medical goods and supplies on the ground. So, if you have simplistic medical equipment, the scenario I always tell people was, if people in the developed world want to donate money to, developing regions' medical care, they always generally want to donate a ICU machine or some piece of understandable technology. Nobody wants to donate surgical clips. It just doesn't kind of happen. It's the priority and hierarchy of medical equipment. But surgical clips are as important as a kind of an ECMO machine, let's say. So surgical clips are so simple, they can be manufactured on site and manufactured locally. The tolerances for them aren't as high. The medical safety requirements for them aren't as high. Local people can't produce an EKG machine, but local people can produce medical clips, scalpel blade holders, low cost assistive braces, and technology. So, it's kind of like the democratization of medical equipment. Local people can produce simple, nothing really beyond simple, but simple medical equipment that they need in their own community quickly, cheaply, and easily. But then it also empowers them to create and innovate. If they can think up a new way or an optimized design, they can then either launch it as a company, or even more beneficially, just share it with other people in the same scenario and encourage them to do the same thing. So, like a democratization and a decentralization of this innovation, design, and manufacturing area.
Yeah, absolutely. Yeah. Now, the Rapid Foundation you founded with Shane, it is very much focused on creating an environment for innovation based on the sustainability goals laid out by the UN. What effect have these goals had on your work, particularly, and how would you encourage other engineers to adopt those goals into their working environments, particularly in response to sort of national and global emergencies?
Like to me, those goals just framed the big problems, like in the major questions. I love difficult problems. To me, the harder the problem, the more like fulfilling it is when you actually solve it. I don't like solving easy things. You go and solve hard things. That to me is an engineer's job, is to solve hard problems. So these goals in particular, the SDGs and the UN goals, they are the biggest problems the world faces. Climate change, equality, education, food use, land use. They're the biggest problems we have. So they're a great kind of framework for engineers to follow if they're looking to do, impact led work, if they're looking for their work to have a real kind of meaningful impact on the society that's around them. So for like young engineers in particular, like they are going to be the biggest problems we'll face in the next 50 years. There's no other problems bar those problems we're going to face. And a huge amount of business and startups and industry and technology and education are going to be developed in the course of solving those goals. So they're a great kind of north star for engineers to look towards, to position their own skills and expertise in these specific goals and areas, because they are going to start to dominate all industry and all of civil society in the future, because we need to solve these. There's no way around it. Like, we don't really need a new social media site, but we desperately need to solve sustainable energy. It's kind of
Yeah,
throw in with the
absolutely.
bigger goal. Like,
Yeah, yeah. Let's get some sort of reality behind this. That there are some major issues to be solved by engineers, by upcoming young engineers, who are really going to be very much embedded in the sustainable approach to problem solving. And I think it's really great to hear about how you have embraced that into your organisation, and made it part of your ethos in terms of what you deliver as an
exactly,
engineer.
exactly. And there is commercial aspects to that then as well. Not in our organization, because we're set fully as a non-profit and we're chasing these complex problems because we like solving them. But business opportunities and startup opportunities, these are inherent in these global goals. There's this belief that the world's first trillionaire will arise from whoever manages to successfully tackle climate change and global energy. And I would agree. There is no bigger problem. So you can have an impact in the world around you and create a sustainable business or opportunity, or make your way in the world, or earn your money as well. It's not an either or anymore. It really has to be both.
Yeah. Yeah, absolutely. You have to be thinking about the wider impact, and I think it's very much why engineers need to be at the table talking about this subject. For too long, they've been sat back and not really been encouraged to discuss the issues around sustainability. And I think it's really great to hear you talk about that. Now, when you started work on the ventilator challenge, what were the biggest barriers you faced in terms of developing the technology, and what were the benefits of creating an open sourced approach to problem solving?
So yeah, the biggest barrier we face, probably unsurprising, was regulation, and regulation being a barrier, but also a very necessary barrier. So we were trying to build emergency critical care medical equipment. These, regulations impeded the speed at which you could develop these solutions. But on the flip side, they are vitally important because they are to keep people safe. The goal of a piece of medical equipment is to extend their life and hopefully improve their way of being. You can't ignore regulation, which will counteract that goal. So the biggest problem we faced in that case was knowing what to solve. At the time when we started it, nobody really knew what an open source ventilator would look like. There was no design specs, there was no operational specs. You kind of had to piece together a functional spec sheet so you could start building it. So that was the first one. But then, as the kind of crisis developed, the medical field and everyone involved in it realized, they said, look, we can't compromise on these safety standards. They have to perform as well as a standard ventilator, or we basically just won't use them. It's there's a piece of medical equipment that makes it even more uncertain whether someone will survive or not is a detriment, not an advantage. So no ventilator is better than an unreliable one. So, regulation and all was one of the big issues, and then how you adapted that to this open source model. So it was complicated because we had an awful lot of people working with us that had no history in engineering, no history in medical device design, no history in healthcare. So they didn't understand the need for these requirements. But we open sourced it for a very specific reason, and that was solely to do with speed. If we open sourced it, we could get thousands of people collaboratively working on it at the same time. We could take these massive iterative jumps. We would work on it in Ireland, and then we'd wake up the next day, and the American team would have progressed it even further. And for at one stage, we had rolling test cycles. So we were developing here in Ireland, and then they were developing in North America, and then they developed in South America, and then they developed in Asia, and then it rolled back around to Europe again. So you could like have a near continuous developmental cycle with people, more brains, more eyes, more insights, more innovations, all kind of compounding each other. And then we were able to share them then with other groups. So, the more ideas you had, the more eyes that were on it, the quicker they developed. And it kind of was like exponentially grew the potential of what we were developing at that time. So that's really why we kind of open sourced it. And then we did it as well to keep people honest, let's say. We did not want this to be a financial opportunity. We did not want it to be a commercial opportunity. It was a piece of equipment to solve a global emergency. That was it. If someone else was able to develop it and get it out there before us, we were fully in behind them and say, look, deliver it. We want to see them delivered. That was our only goal, and open source was the best way to do that.
Yeah, and I think as well, you talked there about people who weren't from an engineering or from a healthcare background, and I think sometimes that kind of keeps it real for us as engineers, doesn't it? It kind of keeps us grounded because they are ultimately the end user in some respect, and so actually being able to check your ideas against what other people think with no with no focus on the technical or the scientific, it is really helpful sometimes, isn't it?
Yeah, massively so. Massively so. Engineers, unfortunately, we see things in a specific viewpoint. Very, very beneficial, but not necessarily always. You know, Engineers are hammers, so they see everything as a nail. So, you know what I mean? We see everything as a technical solution. And in a lot of cases, it's not a technical solution, it's a societal solution, or a user solution, or a community solution. So, having those kind of counterpoints there and other viewpoints to say, is this technical solution really what's needed, or is it something else? Is it a precursor? Is it a kind of post event issue? Is it a funding issue? So having these different viewpoints is something I try to include on every single one of my projects now going forward, and have done for quite a long time. You need contradictory external opinions because you can't be sure the decisions you've made are always going to be right, because in most cases they won't be.
Yeah, absolutely. Now that kind of nicely leads me on to my final question. So what's in the pipeline for you in the next year or so, and what are you hoping that will come out of the COVID response work that you've done to date?
Nobody knows what's in the pipeline for me in the coming year, myself included. But what I want to do is I want to investigate the innovation around these open source interventions. I was lucky enough to be able to found one, but also support numerous other ones around the world in different kind of areas. So I know what I'm going to do is look at that from an engineering and academic perspective to find out how it actually worked. What were the issues? What were the problems? What were the barriers? What were the blockers? And I kind of want to try and map this ad hoc open source community led response to try and build better understanding and better knowledge for whenever we're going to have to do it again. Hopefully it won't be a pandemic, but who knows in our current world. But it could be floods, it could be social unrest, it could be something. People do have the capacity to intervene in these large global problems. So with the lessons we've learned on these projects, I hope to be able to map them and at least provide some sort of framework for people if they were to embark on it again.
Well, I wish you all the best. It sounds fantastic, and I look forward to hearing more about the work that you do in the future. Colin, thank you very much for joining us this evening.
Thank you very much.